But yeah, so I think, yeah, firstly, like, yeah, we just wanted to talk about the voltage stuff just because in the news, yeah, they're saying, there's going to be a voltage limit increase and it's going to allow a whole lot more solar. But I mean, and I'm sure the ministers haven't really explained what that means, and the newspaper articles haven't explained what that means. So, um,
Right.
yeah, even I'm a little bit confused as well, exactly what it means. Yeah, so I wonder, yeah, should
Yes.
as you
From what I
explain.
understand, Australia is Australia's grid operates slightly differently to ours in that it has a lot wider voltage allowances or tolerances. So we're allowed at the moment, our nominal voltage is 230 volts. That's what they call that's our grid voltage. But
Mm,
the way electricity works is that because there's resistance in the lines and when you put more load on, that voltage sags down. What happens is you get a tolerance around that 230 volts. So if you have 230 volts at a transformer and then 50 meters away at the house you turn on the oven, it'll be 230 volts at the transformer, but the oven will pull that voltage down because of the lines have only so much capability. It's much like a hose. If you put your thumb over the end of a hose, you can feel the
mm,
pressure of that hose go up to the pressure that's coming in from the house, and you get a lot higher pressure, but you get little flow. So when in a house, if you've got a little bit of load, you get about a really good, steady, good voltage. But if you
yeah,
get a lot of load, then that voltage sags down a bit. So
yeah,
typically, the way the networks have managed that, not talking about solar at the moment, just talking about load, is that
yeah,
they will set the transformer voltage at the street or at the neighborhood or even further upstream higher than
mm,
230. And they have an allowable maximum they can go to, which is 6%, which happens to be 244.8 or 246 or something like that, 230 volts plus 6%.
yeah,
I should remember it off by heart because so it's 243.8. So it's 244 volts
yeah,
effectively. And
yeah,
so they'll put their transformers up at 240 or 244 volts, and that
mm,
then allows for a lot more load on that transformer to pull the voltage down, and it's still going to be sitting at 230 or maybe 220. And the other side of it is if they did sit it at 230 volts, then lots of load coming on would be allowed to drop it down 6%. And most
mm,
appliances are built and measured and tested to be able to comfortably operate plus or minus 10%. And in most cases, I think it's actually plus or minus 20%. So a modern appliance can handle quite a big voltage range.
yeah. Okay.
So in Australia, that voltage is 10% either side, not
Yeah.
not 6%. So from what I am understanding now is that the regulators have been looking at this, talking with the lines companies because and they've agreed to widen that range up. Now, why it affects solar users so much is because I said when you pull load down to a house, you drop that voltage down. But
Yeah.
when you have
It
a
could be, it could be 220 volts once it's actually in the house and
sure,
used by an appliance.
quite
Yeah,
easily,
okay.
it just depends on how long the lines are, how good the network is at that particular location. So
Hmm.
what happens is that they set that transformer up to say 240, just as an arbitrary setting,
Yeah.
knowing that they're never going to go above 244. They're always going to
Hmm.
be at 240 or below, depending on the load.
Yeah.
So the problem then is if you get a guy that chucks 10 kilowatts of solar on his house,
Yeah.
instead of pulling load down now, he's pushing load back into the transformer. And the only way to get that current to flow the other way is by lifting the voltage up at the
Hmm.
house to be higher than the voltage of the transformer, and then that energy can flow out to the grid.
Okay.
So if you're starting at a 230 volt point, you might end up pushing that up to 240 volts. But if you're starting with the transformers already tapped at 240 volts, that solar is going to push that voltage up. Now,
Right.
one solar array might only move the voltage 2 or 3 volts, which is okay. It's up at 242 or 243. But if you put two on the same transformer, or three or four, or in some neighborhoods now where the developers are saying, oh, every house has to have solar, you're going to get a really high voltage happening. And so what the standards have typically said in New Zealand, the solar standards, what they've said is your inverter has to actually either turn off or ramp its production down as it approaches that high voltage. So the
Mhm.
inverter is sitting at the house, it sees 240
Ah,
volts in the morning, and then the sun comes out, so it lifts its voltage up and starts pushing energy back into the house and then
yeah.
subsequently back into the grid.
Yeah.
And that voltage is going to rise and rise and rise. It's been programmed to either turn off at 244 volts, it will
Hmm.
just go click and turn off. And then the voltage will drop, and then it will go, oh, the voltage is okay. It will reconnect and it will start again. So some inverters you just get, they rise up and then they go clunk and turn off, rise up.
Hmm.
And so the customer is losing all of that potential production and their
Yeah.
solar arrays basically turning off. That's
Right.
one scenario. With the latest standards, the inverters are a bit smarter. So what they
Hmm.
do then is as the voltage rises, they will ramp back their production a little bit. It's not quite as simple as this, but we won't go into electrical theory of power factor and everything like that. They actually shift the way the power is produced, but
Hmm.
effectively it's ramping back the solar production on that site. So
Okay.
again, the customer's not getting what they were promised that those solar panels could produce. It's being limited by the network.
Right. Okay. So
So
even with the new standards, even the old way of functioning versus the new just ramping down accordingly, they're both types of systems are losing out. Is that right?
yeah, correct. Yeah.
Yeah.
So now the new standard doesn't change anything physically out in the field. It simply allows the new inverters that are being installed to operate to a higher voltage. So if we're now talking 230 volts times 10%, that's 253 volts. So
Hmm.
now the inverters are going to be programmed to start ramping back at a much higher voltage, which will, because the network is pretty much tapped at 240 volts, it gives you at least double that headroom to operate. And so
Hmm.
we'll be able to see a massively larger rollout of solar without the limitations that the network companies are putting on people, saying, look, if you export more than 5 kilowatts in this area, you just can't do that. So you have to export the
Right.
limit, because the
Yeah.
most network companies know what the voltages are,
Yeah.
and they also know what that resistance of that line is. So they know how high that voltage is going to climb
Yeah.
based on a certain amount of solar on the property. So
Yeah.
they can run that through their calculator and go, yep, you're approved for 5 kilowatts, or no, you have to limit your export to 3 kilowatts. Um, Sometimes it's a calculation, sometimes it's just an arbitrary guess.
Yeah, so that's the difference, right? So if it really comes down to what the lines company is going to be limiting you at, a lot of them are, it's currently 5 kilowatts. Could those lines companies therefore change, that arbitrary 5 kilowatts? Could they perhaps be looking at, say 10 kilowatts or um, yeah, is that really what this plus
I think I
10%
think if you push
voltage?
them, and I
Yeah.
think if there is pressure from the customer base, but also pressure from the legislators, I think you'll probably find that they will kind of open up that um, maximum export limit to a
Yeah.
point. The um, the reality is, I think they'll probably try and stick to their guns and say, no, you can only export this much. And
Yeah.
in a way, I think if it's a fair level of export, like let's say they said, right, instead of 5, we'll allow you to export 7 kilowatts. In a
Mm.
way, that's going to be better for the solar industry, um,
Mm.
because it then allows more penetration into an area. You could put a lot more solar systems on a lot more houses in the same area if they're all limited to a little bit. But if the first 5 get in and are unlimited, then they've
Mm.
already used that headroom up, and we're back to the
Yeah.
same problem. Yeah.
Yeah.
Um,
So that's up to the lines companies to change those limits themselves. But
well,
yeah,
legally, the voltage limit will be set now. The lines company cannot tell you to bring the voltage back to 240 volts. The the law or the standard that applies to that 253-volt mark, that standard is the 2020, or yeah, the latest standard that will be in force will basically say any inverter that's being installed in New Zealand has to be set to that standard. That's the out of the box way that it's going to operate. However, the network company may still put in an export limit, not based on voltage, but based on the
yeah.
the amount of solar that you're allowed to export to the grid.
Mm.
I don't think that I don't think they should be arbitrary about that. And there are some tests that can be done by the installer or by any electrician to figure out, it's called a NIP test, to figure out how high is that voltage going to go given, say, a 10 kilowatt solar array on that line. And that's pretty
Mm.
simple to calculate. Any electrician will be able to calculate that. And then they could then go back to the lines company and argue, hey, look, this is your impedance. This is your line impedance. This is what's going to happen on the site. We want to be able to put 10 kilowatts in. Um,
Mm.
the problem that I also, if we could cycle back a little bit, problem that I think is going to start happening, which will have to be addressed by the solar installers, um, is existing systems that have been out in the field for quite a while. All those
Mm.
inverters, in fact, legally and technically, all systems that are out in the field now have to be tapped at that 244, 245-volt mark. So
Mm.
they're all still going to operate that way. The new
Yeah.
systems can go higher. But what that will mean is if someone gets a new system in your neighbor's place and your
Mm.
system's been right on the verge of it, that new system is going to continue operating and push the voltage so high that your old inverter is going to turn off.
Ah, okay.
Right?
So that's going to be a big problem.
Yes. So what needs to happen is I think solar installers should have a strategy around their legacy customers, and also maybe an advertising strategy for their region saying, look, if you're finding that your inverter is turning off, please let us know. There's been new laws and we can come and reprogram it to the new standards.
How many inverters can be reprogrammed from anywhere, or do they need to go on site to reprogram them?
Most of them, I think the older ones, they'll need to go on site because it's the grid code, which is called the grid code is the piece of software inside the um, inverter. I'm not talking about the code as far as the law goes, but the actual piece of software inside the inverter that adheres to that law and adheres to
Mm.
that voltage. That's a really basic setup, um, initial setup setting. So the installer who sets the inverter up for the very first time, when he powers it up and he runs through the settings, he sets the date, he sets the time, sets a few other parameters, and then he sets the grid code and then pushes go. The inverter will dump all that program into itself, cycle on and off, reset, and now it's programmed. And for good reason, you can't actually access that program in most cases without a password and without getting into that deep level programming and resetting the inverter basically. So
Yeah.
now I think with the caveat, I think there are a few inverters out there that are able to be updated remotely,
Yeah.
not many.
Okay. Yeah.
Mm.
That
I
could be a
I know
challenge.
of a couple, but I won't say them here. Just let's stay
Yeah.
generic. Yeah.
Yeah. Brand agnostic. Yeah. So, bottom line for the new systems being installed, the benefit of this voltage limit is increase is that um, they can see. Let me see if I can get this right. So they won't be ramped down, less likely to be ramped down, and less likely to be shut down. So
Yeah.
therefore, they're going to be able to export more.
Mm. Correct. So in some cases on the grid at the moment, um, I was talking about the lines company or the network company is tapping those transformers high to
Mm,
handle extra load on their network. In some cases where they upgrade a transformer, they will just arbitrarily tap it at 244 volts. And so
mm,
you can see when you get a system that has data that's coming off the system
mm,
every 5 minutes or something, you can see that even at night time, in the middle of the night, that voltage is up at 244 volts. And then during the peak times, it drops down to maybe 240 or 235 when everyone's using everything. And then it jumps back up again. So in
mm.
that situation, um, a lot of solar inverters that are installed just do not operate right out of from day one. They don't operate, not that they don't operate, they just don't operate to their full potential.
Yeah,
So
yeah.
imagine if you like, there are load control devices on the market. There's many, many of them. Imagine if you had a high voltage, your solar array starts pushing that voltage up in the house, but then your load control unit turns the loads on, which then pulls the voltage back down. And so if you've got loads on in the house during the day, such as hot water, an electric vehicle, a spa pool, swimming pool pump, if you can
Mm,
automate that those loads will turn on
mm.
when the solar production, then that's a double benefit for you. So A, your solar keeps going. It
Yeah,
doesn't just turn off. And B, you're actually using that energy off your solar rather than buying it in from the grid at a later time, like a hot water cylinder when you have a shower at night,
yeah,
or your EV. You can charge your EV from your solar and maybe charge it at the low rate at night, but you don't have to charge it when you get home at 6 o'clock when it's peak time. You just plug it in and start charging. So there's some good control hardware and software solutions out there that, you know,
like help mitigate that problem that
yes,
we're currently seeing with the
help to keep that voltage down in the
yeah.
home,
Mhm.
and has the double whammy advantage of A, that means that your solar keeps going, and B, most of the solar that you produce is going to be used at and is therefore it's being produced at a retail value rather than at the wholesale or the export value.
Yeah.
Yeah.
So, if we can use a typical example of a 5 kilowatt system is a pretty standard size system in New Zealand, and thinking about it, what the current way of it working versus what will happen now with the voltage limits increasing. So essentially they'll be able to export more power. Would you be able to have a rough guess at what the value that would this voltage change would actually mean? Is it, a 5 kilowatt system might be generating $500 of revenue for the household in terms of
Yeah,
export?
it is
What
very
would
difficult to estimate that because every system is different.
mm,
Every area of the network is slightly different. Some
yeah,
areas this is not a problem at all. In
mm,
most areas, actually, I would say it's not a problem because typically what happens, or what has happened in the past, is the new customer has a brand new solar array, he's got his app and he's looking at it and he goes, hang on, this is turning off. He rings the installer and the installer looks at the app and goes, oh, hang on, the network voltage is too high. And then the installer will ring the lines company, the network company, and
Mm-hmm.
inform them. And in most cases, the network company will come back within, sometimes it will take a month, and other times I've seen it done overnight, where they'll send a team out immediately and they will tap that voltage on that transformer down a couple of notches. And then
Yeah.
everyone's happy and it works fine. That's usually caught reasonably early on. I can think of about three situations in the last couple of months that I've been aware of where that's happened.
Yeah.
So there are not a lot as far as improving the existing systems. There are not a lot of existing systems out there that are really struggling with this problem.
Mm-hmm.
But if I don't know, if someone is reading this or listening to it or whatever,
Mm.
and does have a problem, then
Yeah.
now is the time to get in touch or re-in touch with your solar company
Mm-hmm.
and say, hey, can you come and reprogram my inverter, please?
Yeah.
And that,
Yeah.
I
Great
mean,
solution.
if let's make the assumption it was turning off, like there was one system I know that's local to where I am, a new subdivision area, and
Mm-hmm.
their system was turning off probably 3 or 4 hours of the day, right?
Mm-hmm.
So you could say they're missing out on maybe 10 to 15 kilowatt hours a day. So let's call it 10. Um,
Yeah.
and let's call that 30% value. That's $1,000 over the course of a year.
Yeah.
So it's well worth, if they know that their system is turning off, it really is well worth getting someone out to reprogram their inverter on the back of this new standard that's,
Mm-hmm.
or the new limit that's been lifted. Now, there
Mm-hmm.
is always a dark side to the moon. Seems exciting, and it is exciting. I think it's the right thing to do, and it's going to be amazing. But the dark side to it is that this voltage rise limit doesn't just apply to solar installers, it also applies to the network companies.
Mm-hmm.
So now they are allowed to install a transformer and have it higher than 6% to
Mm-hmm.
account for more load in that on that part of the network. I think it's unlikely that they will do that, especially early days, because it would just make them so unpopular. And their engineering, all their engineers and all of their engineering philosophy is built around that 6%. And so
Yeah.
the areas that they have running currently at say 243 volts or something, they can just leave them there and know comfortably now that they can allow more solar onto that area without there being a problem. I
Yeah.
doubt that they're going to go out suddenly and start lifting transformers up to sort of the 250-volt mark. I would be very surprised if they did that. But I think that law, that change does allow them to technically allow them to do that.
Yeah.
Don't
But
give this video to the network companies.
yeah. So,
Keep a
but
little
the
secret.
the real advantage is to solar power system owners, right?
Oh, absolutely. Yeah. And
Mm.
mostly to new ones or ones that are having a known problem. Um,
Mm.
Unfortunately, it may create some problems for the older existing ones, like I said, but that's easy enough to mitigate. Call your
Yeah.
local solar company and get them to come out and reset the grid code to the new standard. Yeah.
Okay. Great. Well, thanks for your time, Ben.
Yeah, sweet.